All right, good morning. Let's get going here. All right, good morning, everybody. Let's get going. I apologize for any background noise, but it shouldn't be too bad. Let's see what we have on the menu today. And there's a question already. Very nice. Can we go over a weighted average example to start off the office hours? Exercise 8.2. Exercise. Okay, let's have a look. 8. I zoom in a little here. Exercise 8.2. Yes, for sure. Let's just get some going here. Yes, there are many different ways to do this kind of question. I try to take an approach that I think might work for most people. But it's certainly not the only method at all. So let's just do the first one, I guess. Yeah, first one's a basic one. So we have a course that has quiz contribution 40% and assignments contribute 10%, final exam contribute 50%. Now I can't exactly remember how we did it in class, but that might not be a bad thing. All right. So how can we lay this out? So this is just number 1. So we have quizzes contributing 40%. So that could be their weight. I'll just make it 40 so we don't get confused between different kinds of percentages. We have our assignments that has a weight of 10, and our final exam has a weight of 50. And then we have in number 1, Johnny scored 80% on his quizzes. So let's say here score is 80% on the quizzes, 30 out of 40 on his final exam. So now here we have the unit, if you will, for the score is a percentage. So I do need to convert his assignment score to a percentage score, 30 out of 40. We can put it in the chat so people can see it. 30 divided by 40 times 100 would be 75. So 75 is the score on the assignment and 82% on the final exam. Which would then give me a score here, 82% on the final. So then what is our overall? Oh man, I cannot write very neatly today. Wow. Let me do a better job here. Overall, it's the weighted average, a weight of 40 with a score of 80, a weight of 10, whoopsie, for a score of 75, a weight of 50 for a score of 82, over the sum of the weights. I'll emphasize it here, but of course that's 100. And then we see what we get. 40 times 80 plus 10 times 75 plus 50 times 82. And I can just divide it by 100. What do we get? 80.5. And of course, that'll be the same unit as the score unit. Is that even what they asked? What is his overall percentage? So this way closely links to how the weighted average formula works. So it might be an easy way. It's just perhaps a little confusing when the weights are given as percentages and the scores, but they have different roles in the calculation. Should we do a more complicated one, or is that good enough?
Would a more complicated one be on the final, or do you think it would
It
be
might,
sort of
I don't
that
know.
level?
By more complicated, I just mean that we have a target overall percentage, like number 4, for example. We have a target 60%, and then we want to sort of reverse calculate what should the final exam score be. Just a little bit backwards, but we can do a number 4. I have to play dumb and not know what's on the final exam. But I don't think they're the worst questions ever. But a question like number 4, we certainly have to be able to do. Let me just position this better, as big as we can make it. It can work. There we go, right at the top there. So Tammy scored an average of 75%. Same breakdown, so let's just set it up. So we have our quizzes. Try to write more neatly here. Assignments, final exam. We have our weights, which is the contribution. And then we have our score, which may or may not require some calculations. That looks nicer. So we still have our 40, 10, 50 breakdown for the weights. Now, scored 75% on her assignment. Okay, so that's right away. There is 75 score. That's easy enough. 18 out of 20, 18 out of 20, 16 out of 20, 12 out of 20 on the quizzes, which we can merge and find an average score for the quizzes. Let's just do it in a calculator. It's not super complicated. Now, there's multiple ways you can do it, to be fair. You can calculate a percentage for each and then average that. But because the totals are exactly the same, you don't have to do that. Let me write this out, perhaps. Maybe someone can get confused here. A safer way is to convert each one, 18, 18, 16, 12, 18 out of 20, 18 out of 20, 16 out of 20, 12 out of 20 to a percentage. And I certainly have to do that if I have quizzes with different totals. I certainly have to. So in order to be as general as possible, let's just do it that way. But because the totals are all 20, there are shortcuts. 18 out of 20 times 100. 16 out of 20 times 100. 12 out of 20 times 100. So we have our percentages here, and they are two 90s, an 80, and a 60 to give us an average of 90 plus 90 plus 80 plus 60, and then we divide that by 4, and we get an average of, oh, 80. Haha, nice. Nice and simple, nice and clean. So worst case, I have to do it this way, but I could have added up all the scores as well, because they all have the same total, so they all have the same weight. But regardless, that is easy enough to do it by way of percentages. Put our percentage signs there to be clear. Then the final exam, we don't know what the score should be, let alone out of 65. But we want to know, we have a target overall of 60. So let's make this question mark in a box. So then overall, our calculation is going to be the same, a weight of 80, a weight of 40 with a score of 80, a weight of 10 with a score of 75, a weight of 50 with a score of question mark in a box. And again, this is not the only way, it's just I'm trying to be consistent with our weighted average formula and what we've done before, even though there are shortcuts if you know what you're doing, but it doesn't promote understanding when it feels a little shaky. So now I have a target of 60, and my unknown is over here. So first of all, let's calculate this and this. It's easy enough. So that'll be 4 times 8 is 32 and 2 zeros. 10 times 75 will be just easy enough to do. And we can merge them together as well. But let's not skip too many steps. Let me just write that out like so. And then we have our 50 times question mark in a box, of course, assuming that we have very little algebra skill. We multiply by 100 on both sides, so that will be 6,000. And for the time being, I'm just trying to solve this equation. I don't care where it comes from. I can certainly put these together as 3,950. And then I want to subtract that on both sides for 50 times question mark. It's good to show stuff in chat, though. It's definitely nice to be able to do it in your head. You don't have to. What do we get here? 2050. Then we divide both sides by 50, so we can write that as a division, or we could write that as a fraction, whatever works for you. So question mark in a box, let's show it in chat, use your calculator, do it in your head, whatever you prefer. 50 divided by 50. The numbers are nice enough, so 41. Now let me zoom out. What does that 41 mean? This is 41%. That's not quite what they're asking. Yes, we now know that she should get 41% on the final exam to reach her target, but the question actually asks, what should she score out of 65 on the final exam. So we can do it up here. So 41%, let's zoom in, of 65, which is the total of the final exam, whoopsie, is 41 over 100 times 65. 41 over 100 times 65. And we get 26.65. So to be safe, she should probably get 27 to just make sure she can't trust half marks or smaller fractions of marks. Probably get 27 on her final exam to make sure she gets above 41, to make sure she gets an overall percentage of 60. So it's just a matter of what information is given, what I want, how exactly do I want it, but it's the same weighted average concept. All right, any questions on that? And of course, this is the more difficult version of that final exam question. The mean, median, mode questions, where are they now? Like this first one, for example, they are definitely much more straightforward, but we want to be ready for both. Okay, so let's go back to page, oopsie, 2 perhaps, and see what's our table of contents. Last time we did a probability tree for conditional probabilities. We could certainly do another one of those. And then measures of centers, weighted average. We've just done one. Unless there are any other requests, I guess I'm picking something. I guess polygons wouldn't be the worst idea. Now, there's not much to do but emphasize that we have to be able to do all of these problems, and only then, same as for the quiz, only then can you be confident that whatever comes in the final exam, we are ready. There's a lot of background noise here. And I mean, there's not much I can do. We just have to understand have a clear concept of what the different polygons are and how I understand the link between them. I think being able to link the polygons is the most important to me. If I think about how I naturally think about these, I don't think about them in terms of sort of cold, hard definitions. I think about more how would I make one? And how do I make one from another one? So if I look at quadrilaterals, for example, I start with the most strict one, which is the square. It has the most structure to it. So the square, all the sides are the same, all the angles are the same, and therefore they are all 90 degrees. Now I can go one of two ways because I have two requirements here for the square. I have the all sides equal requirement and I have all angles equal requirement. If I relax the sides but keep the angle requirement, then I get a more general rectangle. So now I don't need all the sides to be the same, I just need the angles to be the same. So I can stretch this out a little bit. And as a result, the opposite sides are still the same. If I keep the sides requirement, but relax the angle, then I get a rhombus. Let me draw my rhombus here in a somewhat good looking way. So I still have all the sides being the same, but now the angles aren't all the same. And a side effect of this, still pretty strong structure, is that opposite angles are the same. Let me just read the chat question here. Could you explain a rhombus with at least one right angle, but explain why a kite shape is not one? One thing at a time. I'm just trying to create a map in my head that makes sense to me without trying to memorize definitions. I think people sort of lose their way when they try and memorize definitions that aren't really the words they would use, and they're trying to adjust their natural link between these shapes to fit some textbook definition. And there are many ways to see the connections between these. Okay, so now if I take a rhombus, it has, so let's write that down here. Rectangle is at the top, rhombus at the bottom there. If I now take a rhombus and I have the additional requirement that I have a right angle as well, well, then I'm going to go back to the square. So a rhombus with a right angle immediately means, let's suppose I want to have a rhombus. Let's write that down. So this is a way. This is how I see these things in my head and the connections. I'm not thinking of a cold definition. I'm thinking about the key properties of the shapes and what links them together. Rhombus with at least one right angle, right? Let's suppose that's our question. Is that possible? What would that look like? If it's not, why not? And so on. So now in my head, I'm thinking, okay, well, I need the rhombus. I'm picturing my rhombus. One second, I'll be right back. All right, back. Whoopsie, that's an unpleasant line. So I'm picturing a rhombus in my head, but now I have to have a right angle. So let's make it this top one, right? So now I'm sort of stuck with a right angle. I know all the sides have to be the same. And I know this general rhombus shape. If this angle is my right angle, that means the opposite one has to be as well. So now I have to go back and adjust my thinking here of my picture that, oh, well, I'm kind of stuck. The opposite angle now has to be a right angle as well because that is the property of the rhombus. So that forces this one as well. And I know the other ones are, the other two angles are equal as well, so they have to be right angles as well. So requiring at least one sort of has this overflow effect that they all eventually have to be. And because it's a rhombus, of course, all the sides are the same, and I therefore get a square. But notice how I understand the key properties of the rhombus. I don't ever think of, oh, my definition says only this, and now I have to somehow figure out a conclusion. No, I think about how these shapes are connected, their key properties, and how they can be the same and different. Now, of course, we can relax the rectangle, we can relax the rhombus as well. In different ways, I'll focus on the rhombus since that was part of our question. Now, the rhombus has the property still that I have all the sides equal. If I relax that, not completely, in a certain way, let me go rhombus here. I'm gonna have to draw the rhombus again. I'm gonna have to draw the rhombus again, just so I have it. Come on, rhombus, you can do it. That's not a very pretty rhombus. Need to be professional. Draw a rhombus. Okay, I'm going to go with that one and not embarrass myself any further. Okay, so I have this rhombus picture in my head, and I can generalize this in two ways. Now, I'm not saying I couldn't have done that with a rectangle. I could have, but this is one way. Same as what I did for the square. I took the square, which had an angle requirement and a side requirement, and relaxed just one of them and created two different sort of families. I can do the same thing here and relax the strict all sides the same requirement, but in two different ways. I can still require that opposite sides are the same length, but not all of them. And then I'll get a parallelogram. Now, admittedly, that's not the only way we could get to a parallelogram, but it certainly is one way. Parallelogram. Parallelogram. Whoops, can't spell. That is ugly. Parallel. There's my L. Get in there. There we go. And I can relax the side requirement in a different way by requiring that two adjacent connected sides are equal. And the other pair of connected sides have to be equal. So now people draw it on the side here, but it doesn't really matter how I do it, right? Those two connected ones are equal, and the other ones, the other pair might not be. They equal themselves, and then I get a kite. This is not the only way, but it's a way to see how those more general shapes connect to the rhombus. I could also go from the rectangle and get a parallelogram and then understand the link between those two. But if it's specifically rhombus based, I can think of it like this. So I've relaxed the more strict rhombus in two different ways, and I create two different families. So just going back to your question, we explained why a rhombus with at least one right angle is a square. A kite, so now is the question here. I think I understand the question. Can we get a kite with at least one right angle. Is that possible? It is certainly possible. I do not, with a kite, have the requirement that this angle, that opposing angles are the same, especially opposing angles, how should I say it? The angles that are between equal sides, they are opposite to each other. If those sides are not the same length, then they won't be equal. These ones will be equal. 3 lines, but not the ones squeezed in between the equal sides. So if I'm required to have a kite, and I'm required to have at least one right angle, sure, more right angles and I'm gonna head back to the square. But I just need one. So I can make my square angle here and have these two sides be the same. While still being a kite, I am not restricted to the other angle being the same. That could be a different angle. And I'm still a kite and I have a right angle. So this requirement of having at least one right angle in a kite doesn't have this overflow effect. Where is it? Doesn't have this overflow effect that, oh, now another angle has to be 90 degrees, therefore the other ones, and now all of them are making a square. I don't have this sort of chain of events anymore. But again, never at any stage did I look up a definition and try and match it and make links. It's too cold, it's too detached. I want to have a more natural understanding of how these shapes are connected. There isn't just one. I could go from, for example, a rectangle and think of a parallelogram in a completely different way. If I look at my rectangle, it reduces to the same thing, but it doesn't sound the same. So there is my rectangle, and of course all the angles are the same and therefore 90 degrees. A side effect consequence is that opposing sides are the same. Let me fix this angle here. I can think of it in a relaxed, I can relax the angle requirement by thinking, I'm going to fix this bottom edge. I think of some rubbery material, like an eraser or something. And I'm going to fix that bottom one somehow. But this is a deformable shape, and I'm going to shift, I'm going to push the top to the one side horizontally. And then what I'm going to get is my parallelogram, where the requirement is that I still have these horizontal, it doesn't look the best here, does it? Still these horizontal shapes. Horizontal lines rather. This line's bothering me. Let's fix it. And a side effect is that these two are parallel as well. Now there are other properties that I don't necessarily care about, but I get a parallelo. Man, good with the program here. Program. Now, I did not spell that right, did I? Not at all. Multitasking. Multitasking is not my strength. Parallelogram. There we go. Now, doing it this way, I get the parallel side aspect of the parallelogram more so than the parallelogram kite distinction. but it's all the same shape. Just connected to different sort of base shapes, and how did I relax that more structured rectangle? How did I relax the more structured rhombus to sort of have this parallelogram family that they both belong to, but a rhombus and a rectangle uh, aren't necessarily the same. So it's just some way of sort of navigating this. Not the only way, but find something a little bit more, what's the word I'm looking for? Not natural. Organic, I think, is the way, rather than a sort of a more sterile, cold definition that you are trying to conform to. There are many ways to think about these things, and once you start doing that, it's much easier to teach. It's much easier to adjust between concepts because you found something that's a little bit more natural for you, or something like that. Let me know if there's more questions on that. Otherwise, I think we're good to go further. I need to check. Where are we? Where are we? Probability. Now, Euclidean constructions I can't really discuss here because I don't have the compass tool to make circular arcs and things like that. But excuse me, all the steps are there. It's going to be uh, one of the ones we've discussed. You can follow the steps and you just have to um, be accurate enough. Measurement, we could talk about some measurements. Yes. I do want to emphasize, actually, I'm going to look at our test. Let me just find our quiz 2 while you think of more insightful questions to ask, so we can see exactly which reference unit conversions will we have. Let's see here if I can find the test. That would be quiz 3, wouldn't it? Quiz 3. Get away from me. Let's see here. Zoom, zoom. Page. There we go. All right, there we go. So there, so here's our standard table. So it's not too overwhelming. There aren't too many things to work with. Simplify it a little bit. And the question will ask specifically to use this table. So you have to show, if I have to convert 17 meters to yards, exactly how am I doing it using this table? Not, oh, I used Google, but you can certainly use Google to check your answer. Nothing stops you from doing that. But you have to show your work and how it would be done by hand. That's one thing. And another thing is the problems do not cover area conversions. And I've said that in the video, Monday's video. And for that reason, we want to be able to do exercises 11.4 to 6 as if they are problems. So if you're anything like me, I don't remember exactly what the answer is. We can see them as problems and do them again. But first, let us see some interesting... Man, these are not very interesting problems, are they? This one stays in one system. This one stays in the English system. Where's the one that I cross over? Those are way more interesting. Let's go look for those. Like these guys, 11.3. Those are way better. All right. So I don't know. Let's do 1 and 3. I don't know. Unless there are any other questions, which I do not see, I will keep going. I'm always paranoid when it's so quiet. Can anyone even hear me? I assume so. Don't know. But talking to myself is a good time as well. Yeah, what they were a little backwards, I think, in terms of the complexity. But we could do yours, yeah. Sure, it's fine. Doesn't matter. Just want some. Think of the worst question I can get, and then anything else is not that bad. So let's do conversions. 182 centimeters to inches, completely random, of course. So I luckily have the inch to centimeter simplified, but still conversion. So I'm going to start with my 182 and my unit, and then I'm going to multiply with my reference pair, I'll call it. So I'm going to have to put centimeters at the bottom, inches at the top. So 1 inch, 2.5 centimeters, so that I can check, yeah, the centimeter unit cancel with this bottom one, and I'm in the right unit. Then let's do it. 182 divided by 2.5. 72.8. And of course, then people don't really have a good sense of what that is, but that would be done. You can, of course, then go a little further and say, well, I know that 12 inches make 1 foot. So how much would that be in feet and inches? So 12 inches equals 1 foot. 72.8 divided by 12 will be 6, and 6, let's say remainder 0.8, if you want to call it that. So this would mean that 6 feet and zero point 0.8 inches, if you want to go that way. It's not quite another inch, is it? Because I need a 12 to be another inch if I use this conversions in the table. Now that one was easier because, not that you have to do feet inches in combination. That one was easier because the units involved were immediately in the table already. So let's get something that is perhaps not right away there. Kilometers to miles as well. That's already there as well. That seems too easy as well. Man, is there anything that's not easy? Feet to meters? Feet to meters, that's not immediately there. Okay, so let's do that one. So exercise 11.3, number 1. Exercise 11.3, number 1. What was it? 50 feet into meters. 50 feet into how many meters? So now I have to make a plan based on the table that I have. Let's make a plan. No one is watching on YouTube. That's nice. That feels amazing. From feet, what is the quickest path I can make, the shortest path rather, to get to meters. I'm going to go by this. I can go by the centimeter route. So I can go feet to inches, inches to centimeters, centimeters to meters. How many was that? That was feet to inches, one step, inches to centimeters, two steps, centimeters to meters, three steps. That's not bad. My alternative is to go feet to yards. Wow, that's loud. Feet to yards, yards to miles, miles to kilometers, kilometers to meters. That seems worse. That seems worse. This table will be just like the quiz 3 page. It'll look the same. So yes, because I'm asking you specifically, don't just convert this in general, use this table. So I'm going to have to give you the table. Absolutely. It'll look the same. I literally copied the quiz pages and changed some numbers. Not because I'm lazy, but that's really a separate issue that I don't want to get into now. Anyway, it will not look unfamiliar. So we're going the smaller route, we said. So we're going to make a plan, feet to inches, inches to centimeters, centimeters to meters. That seems to be the most efficient based on the table. Now let's do it. 50 feet. So I'm going to need feet at the bottom. Let me just triple check here. What do we have? Feet, inches. We do have that. Now I'm not worried about filling these in. I'm planning. Feet, feet cancel. So I'm currently in inches. Then I need inches at the bottom, centimeters at the top. So now I'm in centimeters. Then lastly, centimeters at the bottom, meters at the top. So now I'm in my desired meters. Now I look it up in the table. We just have to flip back and forth a little bit. 1 foot, 12 inches. 1 inch, 2.5 centimeters. 1 meter, 100 centimeters. That one was there as well over here, second line. And then I just multiply. I can ignore the ones because they don't change my answer in any way. So let's do it. 50 times 12 times 2.5, ignoring the noise. And we get stuff breaking in the background apparently. What do we get? MathBot, do your job. 15. Oh, wow, that's nice and clean. Wow. Now, if you Google this, I'm just going to do that out of curiosity. 50 feet in meters. Let's see what Google says. 50 feet in meters. It says 15 point, I can show you here. 15.24 because we simplified some of our conversion pairs. It's not actually 2.5, right? It's 2.54. And some of these others are simplified as well. So if you check, no, that is not going to be exactly, and you can't use 15.24 because then you didn't use this table. That's how I get you. Are there any questions on that so far? Oh, we have one person watching on YouTube. Welcome. That's so exciting. On YouTube, I can create more production with an introduction and a be right back screen. So feel free to go look at the YouTube version and let me know these new ones starting yesterday if you like that a little bit more. But live, there's a little bit of a delay. Anyway, I digress. So we want to practice some area conversions as well. So let me just see here. Wow, time goes really fast. when you're converting units. This one stays in the SI unit system, boring. This one stays in the English system, a little bit less boring. But the exercise 11.6 gets me to cross over. Now decameters, that is not covered, so I won't in the table I'll give you, so I won't ask those, of course. Yours, you want to do 12 square meters to square feet. Yeah, we have a similar one there. That's definitely one that we need to be able to do, so let's do that. I'm curious if there's any practical significance to that question. 1 second, I will be right back. And we're back. Okay. Uh, so you want 12 square meters to how many square feet? All right. So we just have to make a plan. Make a plan. I'm just paranoid here. Am I actually doing this? Yes. What is our plan going to be? Well, we still have the same table. So we're going to have to really take the same chain as meters to feet. Meters, one option is to go low or to go high, right? Low would be meters to centimeters, centimeters to inches, inches to feet. It's not terrible. We could do that. Or we could go high, meters to kilometers, kilometers to miles, miles to yards, yards to feet. Oh, that does not seem better. Seems like the lower path is always the nicer one to take. But you do have the option, and I'm stuck with this table, right? Do you agree that low seems to be the better path again? I was hoping it would be high, but it doesn't seem to be. Is anyone out there? Not that I need you to be. Uh, well, for your benefit, I do. So we're gonna make a plan to go low. So I'm gonna have to go square centimeters, it seems like. Then square inches. And then I will be able to go to square feet. Okay, that's not bad. It's a decent path. It's not going to take that long. I just have to remember that I have meters times meters. So I'm going to need two of these conversion pairs taking meters to centimeters. Meters at the bottom, centimeters at the top. I just have to double up everything I do. Now there are other ways to do this, but I'm stuck with the table, so I'm kind of out of options. I'm not doing, filling in anything or doing any calculation. People are so eager. Oh, calculate, calculate. No, that comes at the end. Planning, that's what comes first. Then I have to convert each centimeter unit to inches. And there are two of them. I thought someone was typing. So 1 centimeter cancels with that one. 1 centimeter cancels with that one. And then I have to go inches to feet twice. And then I am in the right unit, which would be feet squared. Now I fill it in, meters to centimeters, 1 meter, 100 centimeters, 1 meter, 100 centimeters. Doesn't really get any easier than this, let's be honest. 1 inch, 2.5, 1 inch, 2.5 centimeters, 1 foot, 12 inches, 1 foot, 12 inches, ready for the calculator. My planning is done. Let us do it. 12 times 100 times 100 divided by 2.5 divided by 2.5 divided by 12 divided by 12. Very exciting. And we get 133 point, squeeze it in, square feet. Let us see what Google says. I want to know. I want to know. Can I even do it? Well, square meters and square feet. Yeah, I'm losing a little bit of accuracy here, of course, because of the many conversions actually happening, right? So I'm a little off because there were a couple of inaccuracies here that sort of doubled up, giving me making me deviate further and further, unfortunately. So I can't really use this 129 in the exam, but it is there for simpler calculations to verify that you're sort of in the right size number. All right. Unless there are any questions, I think that is another successful session. Now keep in mind that I understand you're eager to voice chat and have discussions. We only have tomorrow left. Then our exam is on Friday morning, and you're gonna look back and think, oh, if only I chatted in Discord more. Now I'll never have the chance again. Think about that. Until next time.